Write down the modulus and argument of the complex number w equals to -1 plus I. So very easily we want to find the modulus. It's quite easier. So the mod of w is just equals to square root 1 square plus -1 square, correct? And answer just gives us to be square root 2, right? And the argument of w, right, will just be equals to, if you can observe, -1 plus I, what you can do is you can draw the Argand diagram. This is real, this is imaginary, right? -1 plus I will be somewhere here, right? And you can see that this is just equals to 3 pi over 4. Okay? And hence find the set of the values of integers for which w power n is imaginary. Right, so if this is our w, we know that our w can also be written in this form, right, which is just square root 2 e to the power of I 3 pi over 4. Or if you write it in the polar form, this is just square root 2 cosine 3 pi over 4 plus I sine 3 pi over 4. Right, so now they are talking about finding Wn. They're finding about Wn. So which means we need to know something. We need to know how Wn looks like. So Wn, you go forward, Wn, right? Basically, it's just to take this power n, right? And you can see that it's just square root 2 power n e to the power of I 3 pi over 4 n, right? Or we can say this is the same as square root 2n. Alright, and I hope you still remember that, because you can see that actually this is the argument, this is the new argument of Wn. We are actually at cosine 3m pi over 4 plus I sine 3m pi over 4. Alright, next is that we want Wn to be imaginary. This means that we want the real part to be 0, correct? We want the real part to be 0, right? So how do we create the real part to be 0? This just means that we want cosine 3m pi over 4 to be equal to 0. Alright, you know that in the cosine function, for my cosine function to be 0, if you remember the graph, for cosine x equals to 0, this means that x is equals to like a multiple of like pi over 2. So it could be like negative pi over 2, negative 3 pi over 2, negative 5 pi over 2, correct? It can even be things like negative 7 pi over 2, okay, so on and so forth, right? So why am I using all the negative integers? Because the question says so, they are looking for negative answers. Okay, then what does it mean? Okay, so from here we have some sort of equation. Let's multiply by 4 on both sides. What we can do is from here, I want to find n, right, eventually. So it's like I'm dividing by 3 pi over 4. Right, and if I take all my answers, and if I divide by 3 pi over 4, likely I'm going to get like 2, like negative 2 over 3, negative like 6 over 3, negative 10 over 3, so on and so forth. Right, and find the set of values of integers n for which Wn is imaginary. So this is the set of integers, but is there any way for us to characterize it? Actually, it's possible. So you think about it, it looks like there's a common thing, right? So n could be equals to, like for example, this can be negative 3 times 1, right? This can be negative 2 over 3 times 3. This can be negative 2 over 3 times 5. So you can see some sort of like an AP where there's a common difference of 2, right? So we can say that n in general can be equal to negative 2 over 3, right? And then for the first term, it could be something like 2k, probably like 2k minus 1. Like 2k because odd number, this one is an even number, odd number, this one is an odd number, okay, where k is